we have already discussed the normal distribution, what we're going to discuss now is how to apply it and use it for applications. We're still going to be using the z-scores, and the z-scores, remember, are the value minus the mean divided by the standard deviation. And it always depends on if you're talking about the population or a sample. You still calculate them the exact same way. How we're going to be finding these is we're first going to draw the normal curve and shade the desired area, just like we did when we were finding the area underneath the curve. But then we want to convert our x value into z values using this formula here. And then we find the corresponding areas using the standard normal curve. So let's look at an example. We're going to look at teacher salaries. The average annual salary for all U.S. teachers is $47,750. Assume that the distribution is normal and the standard deviation is $5,680. So since it says for all U.S. teachers, this is going to be your mean and your standard deviation. We want to find the probability that a randomly selected teacher earns between $35,000 and $45,000 a year. So we already know some information. So we want to first start by drawing our standard normal curve. And when we do, we notice that it gives us our mean as being $47,750. We want to find the probability that a teacher earns between $35,000 and $45,000 a year. So $45,000 is going to be over here, and $35,000 will be about right here. So we want to know what this area or the probability of this happening is. Now, in order to find this, we need to change both of these numbers into z-scores. These right now currently are x values. So what we're going to do is change them both into a z value. So in order to do that, we're going to start out and change 45,000 minus 47,750, divide it by your standard deviation, which is $5,680. Let me scoot this down a little bit. So 45,000 minus 7,750 gives us negative 2,750 divided by 5,680, which gives us a negative 0.48. And remember to always round your z-scores to 2 decimal places. We're going to do the exact same thing for 35,000. So I'm going to come over here and find out what 35,000 minus $47,750 divided by $5,680 is. And that gives me a negative 12,750 700, and that's negative 12,750, and that should be a 2, and that's looking very sloppy. Let me try to get that a little bit better. There we go. Divided by 5,680, which gives me a negative 2.24. So these are my two z values. Remember, since I want the probability between these two numbers, I have to look up both of them and then subtract. Remember, I do not want to subtract my z values. I want to look up each of the values on the table. When we look up the values on the table, you should have your table there available for you. And if I look them up on the table, negative 0.48 to the left gives me a probability of 0.3156, and a negative 2.24, if I look it up on the table, gives me a probability of 0.0125. And then I need to subtract these. So the probability that a teacher earns between $35,000, and that should be a Z instead of an X. Nope, should be an X. And $45,000 is going to be 0.3156 minus 0.0125. Subtract those out, and I get 0.3031. So the probability that a teacher earns between $35,000 and $45,000 is 0.3031. Let's try another one. We're using the exact same information. We're still looking at the teachers, but this time we want to know what's the probability that they'll earn more than $40,000 per year. So we're still going to draw our normal distribution curve, and our mean was 47,750, but we want to know more than $40,000. So more than means we're shading to the right this time. So this time I want to change my $40,000 into a Z, and so I'm going to have Z is equal to 40,000 minus 47,750 divided by my standard deviation, which is still 5,680. I get a negative 7,750 divided by 5,680. And when I do that calculation, I get a rounded number of negative 1.36. I want to look that up on my standard normal distribution chart on the negative side, but we have to remember that when I look that up, I get a number of 0.0869. What that gives me, though, is that gives me to the left. it gives me this portion over here. So it gives me to the left. I want to the right. I want more than. So the probability that x is greater than 40,000 is actually equal to 1 minus 0.0869. When I do that subtraction is 0.9131. Remember, if I want more than, greater than, to the right, anything like that, I have to do the 1 minus. So the probability that a teacher earns more than $40,000 a year is 0.9131. So you have to go back to your rules that you've previously learned about the standard normal distribution, and also using the standard normal z-scores, and combine those. Now then, a normal distribution can also be used to find specific data values if you're given the percentages. When you're given the percentages, you are actually going to be looking them up in the center of the table, things of that nature. Remember that our standard normal formula looks like this. Z is equal to x minus the mean divided by the standard deviation. Well, what if I want to solve this for x? I can do a little bit of algebra here. I know this is not an algebra class, but we can manipulate this, and I can solve this formula so that I can solve for x. The first thing that I want to do is I want to undo this division that I have here. So I want to get rid of the standard deviation on the denominator. In order to undo division, the opposite of division is multiplication. So I'm going to multiply both sides by my standard deviation. When I do that, it will cancel these out, and I'm left with standard deviation times z is equal to my x minus the mean. And I'm still wanting to find my value here. So if I'm still wanting to solve for my x, that means I want to get rid of my mean. Well, right now the mean is subtracted. The opposite of subtraction is addition. So I'm going to add the mean to both sides. When I do that, it cancels these out. And I'm left with standard deviation times z plus the mean equals x. And it gives me this formula that I can use. Now, most of your formulas, you have a formula chart, things of that nature, and this formula is usually written like this: z times standard deviation plus the mean. It's the exact same thing, and you use this in order to find the specific data values if you're given percentages, if you're given the area. Now then, if you're given the percentages, we want to follow certain steps. we first want to draw a normal curve just like we always do, and we want to shade the desired area that represents the probability. Then we want to find the z-value from the table that corresponds to the desired area. We can't use the area or the probability, we have to use the z, because in our formula it uses the z. So we have to look at that z-value. Then what we do is we plug it into this formula and we do the calculation. Let's look at an example and see if we can do this. So to qualify for a police academy, applicants are given a test of physical fitness. The scores are normally distributed with a mean of 64 and a standard deviation of 9. If only the top 20% of applicants are selected, find the cutoff score. Okay, we're looking at the top 20%. So let's think about this. We have standard normal distribution, and we want the top 20%, so that's going to be up here, the top 20%. So that means that this right here is going to have 20% or 0.20 in it. So I want to find the z that goes along with it. Now let me think about this. Remember that our table only gives us the area to the left. It doesn't give me the area to the right. So how much is this area to the left? If to the right is 0.2, this is going to be 1 minus 0.2, which is going to be 0.80, 80% of them. In other words, 80% of the applicants don't make the cutoff. So this is what I actually look up in the center of my table. Remember, we did this in a previous video, looking them up in the center. Now let me get the chart in here. I've got to insert that for us. So let me insert the normal distribution chart for us. Okay, so I want to find 0.80 on my chart. Well, it's greater than 0.5, so I want to use the positive value. So I'm going to come over here and I want to look at for 0.80. Well, here's 0.7, here's 0.81, so I need to be in this row right here. Here's 0.79, 0.79, 0.79. Here's 0.8023. So I'm actually, if I look at this, I can't find exactly 0.80. I can find two numbers that it's in between. When you find it that it's in between like this, what you want to do is you want to use the one that it is closest to. So looking at 0.7995 and 0.8023, it is actually closer, 0.80000 is closer to 0.7995 than it is to 0.8023. You want to use the one that it's closest to. So whenever I do use this one, the z that corresponds to this is going to be 0.84, because I use this and this. So my z that we will use is 0.84. Now that doesn't give me the cutoff score that my question actually asked for. This just gives me the z. I want to find what the applicants have to make on the cutoff score. So in order to find the cutoff score, I'm going to use the formula x is equal to z times the standard deviation plus the mean. Now in the problem, it told me that the mean was a 64 and the standard deviation was 0.91, and we found our z to be 0.84. So I'm going to come back over here and plug those numbers into my formula. 0.84 times my standard deviation plus my mean. So I get 0.84 times 9.1, which is going to be 7.644 plus 64. And my pen is messing up again. Let's see here, 6.44 plus 64 is going to be a 71.644. Now then, think about this though. We found that the cutoff score, we needed at least a 71.644. Think about any type of test though. Do most of us give decimals of a test? No. And think about your mean. That's in whole numbers. So we need to round this up because it's a minimum. So we're going to have a cutoff score of 72. So an applicant needs to make a score of 72 to be selected. Now it's one of these cases that we've gone through a couple of different types of problems, and it's going to be, you really have to practice reading the problems and determining, do I need to convert them into z-scores first, or do I need to look them up in the table? One key is, does it give me a percentage or a probability? If it does, that's where we need to look them up in the table first. If it's asking for the probability, that's where we need to convert them into z-scores first. Look at the different types of problems. Look and see, is it asking for greater than, less than, in between. You really have to pay attention to those types of words and everything. Practice some of these, and if you need help, please let me know.